Hello, thanks for watching this presentation. Originally presented at Furnaces North America 2016, and let's just get into this presentation. So first, a little housekeeping, a little info about me. My name is Todd Wenzel. I'm president of Blue Streak, and I've been working in the metals treating industry since around 1990. I've been a software architect and database designer for a long time. Blue Streak, our product is a full quality management system and manufacturing execution system, and it's really the fourth major version of this type of software that I've designed in this industry since 1990. And the last thing here is in 2015 Blue Streak was honored with an award from Metal Treating Institute as Associate of the Year, and my understanding is that's the first time a technology company was ever given that recognition, and we are very honored to have been recognized with that. Alright, so some key takeaways for this particular presentation is you should have a better idea of how to determine your cost of quality or your cost of poor quality. The second thing is it's possible to dramatically reduce your cost of poor quality. The third thing is a fully integrated quality management system is a necessary requirement. And the fourth one is with a properly managed and systemic quality management system, you should be able to answer yes to every auditor's question. So what do I mean by that? Well, yes, the furnace was operating according to 2750E. Yes, the operator was trained and approved to perform that operation. Yes, the hardness tester did pass a calibration check within an hour of being used for this work order. Yes, the hardness tester was operating according to E18. Yes, the operator was trained and approved for E18 hardness checking procedures. Yes, the correct furnace was used according to the customer's PPAP. Yes, there was a risk analysis completed for the part or for the vendor product or for the vendor. Yes, the parts were soaked for the correct time period and at the correct furnace conditions. Yes, we hardness tested the proper quantity based on the sampling plan specified by the customer. Yes, we have a concession granted note from the customer accepting the slightly hard parts. Yes, the operator did see, acknowledge, and follow the corrective action. Yes, because we couldn't have shipped these parts unless every step along the way the answer was yes, and the parts were able then to continue to the next step. So the cost of quality, it's a fairly hot topic right now. There's even an MTI committee that's been organized to try to figure out what the cost of quality is and what to do with that and how to convey that information. You probably have had discussions about what your quality costs your company and how do your quality costs compare to other heat treaters, or perhaps maybe how do you convey to your customers and prospects your dedication to quality and the fact that that dedication requires a significant ongoing investment that our competitors don't do. So our prices are going to be higher, a little, or at least a little higher because of that quality commitment. Or you probably have had some other discussions about that. But really the simple fact is, with few exceptions, your average customer or prospect can't really understand or doesn't care about what you spend on quality. They assume they will get the same result and the same quality from you or your competitor or competitors. They only really get concerned about quality when there are some obvious problems that arise from the heat treating that maybe you provided them, or if you can't turn around the parts fast enough, then they start to seem to get concerned about that. So here's a question. Obviously you can't raise your hand on this video, but does a heat treater who has a higher cost of quality necessarily have better quality than a competitor who spends less? So you think about that a little bit, and really the answer, at least in my mind, is no. It's kind of like equating somebody's health based on how much they spend on health care. So obvious example, you have two males, both age 50. One doesn't really spend much on health care, doesn't really have any issues going on, maybe he has an annual physical, and then you have another one who's had quadruple bypass surgery, is on a zillion meds, and lots of complications to that. So if you looked at the cost of their health care and try to equate that to how healthy somebody was. If that was your only metric you're looking at, then you would say, well, the guy with the quadruple bypass surgery is much more healthy because he spends a whole lot more on healthcare than the other 50-year-old who just has annual physicals. So it's a similar type of analogy there. So here's another question. What is your definition of the cost of quality? So I've got a couple options here. The first one, do you think it's the annual costs for obtaining and maintaining your quality accreditations? So things like registrar costs, external audits, internal management time, things like that. Do you think that's what your cost of quality is? Or B, or number two there, is it perhaps the total cost of your quality department? So then you have to look at things like, well, salaries and benefits, equipment, consumables like thermocouple wire or probes and things like that. The third option, do you think it's the cost of not creating a quality product or service? So, or is it something else? So what's your definition of quality? Well, I believe with Philip Crosby here that quality is free. The low quality always comes with a price. So Philip Crosby, you may have heard of him. He's an icon in the quality disciplines. He demonstrated what a powerful tool it could be to raise awareness of the importance of quality. So he referred to the measure as the price of nonconformance, and he argued that organizations choose to pay for poor quality. He really had four absolutes of quality management. First one, quality is defined as conformance to requirements, not as something subjective like goodness or elegance or it's pretty. That's not what a definition of quality is. The second is the system for causing quality is prevention, not appraisal. So how you get quality, since it's free, is preventing bad quality from happening and not always having to investigate and test things. That's the appraisal part. The third one, the performance standard for quality must be 0 defects and not just it's close enough. And the fourth one is the measurement of quality is the price of nonconformance, not of some indices. So another leader in the total quality movement is Armand Feigenbaum. And he breaks down his definition of quality costs into two broad categories. He's got the costs of control and the costs of failure of control. So on the side of costs of control, he breaks that further down into prevention costs. And prevention costs are incurred to prevent or avoid quality problems. These costs are associated with the design, implementation, and maintenance of the quality management system. They are planned and incurred before actual operation, and they could include things like product or service requirements, that's the establishment of specifications for incoming materials or processes or finished products and services. It could be quality planning, that's the creation of quality control plans for your quality and reliability for operations, production, and for inspection. It could be quality assurance, which is, he defines it as the creation and maintenance of the quality system itself, and training. So development, preparation, and maintenance of these various training programs. The second cost of control are evaluation costs, and these are associated with measuring and monitoring activities related to quality. So these costs are associated with the suppliers and customers' evaluation of purchased materials, processes, products, and services to ensure that they conform to specifications. So they could include things like verification, that's checking of incoming material, process setup, checking products against agreed specifications, quality audits, confirmation basically that your quality system is functioning correctly, supplier rating, assessing and approval of suppliers' products and services. The second category here is the costs of failure of control, and he breaks that down into two subcategories here. Internal failure costs. These are incurred to remedy defects discovered before the product or service is delivered to the customer. So they could include things like waste, which is really performance of unnecessary work as a result of errors, poor organization, or communication. It could be scrap, a defective product or material that cannot be reworked, used, or sold again. It could be rework or rectification of these issues, and it could be failure analysis. That's the activity required to establish the causes of these internal failures. And the second subcategory here is external failure costs. And these are costs that are incurred to remedy defects that are discovered by the customers, not by you, but by the customers. And they could include things like repairs and servicing, both return products and maybe those in the field, warranty claims of failed products, maybe they have to be replaced, or services that have to be reperformed. Maybe you have to do something with the heat treating again under some guarantee. Complaints, so all of the work and the costs associated with handling and servicing customers' complaints, and of course the returns, handling, and investigation of rejected or recalled products, including transportation costs. So really, Feigenbaum, in his mind, he says the total quality cost, or total cost of your quality, is really the sum of all of the costs of control plus all of the costs of failure of control. So just a quick example here. Apple, if you had the pleasure of having an iPhone 4, which came out in June of 2010, there's a good example of, I guess, cost of quality. If you remember the controversy around that, the cell phone would predictably drop calls when you place your hand in a certain position. Basically, if you held it in your left hand, like the picture in the lower left shows. So when you hold it in your left hand and that bottom left corner of the iPhone is kind of tucked in a little nook of your thumb in your hand, that's where the antenna was. So if you held it that way, the call would drop every time, and there's many videos people showing this, what's happening. So Steve Jobs, his reaction to this was kind of not the greatest customer relations, but he said, don't hold it that way. So, don't hold it in your left hand. You're supposed to hold it in your right hand, like the diagram shows. So obviously that's not a really great reaction to this quality problem. So ultimately this recall of the iPhone 4s cost Apple anywhere from $130 to over $500 million. And they're pretty secretive of what their actual costs were. So you remember our friend Philip Crosby and his philosophy of do it right the first time. Well, what he advocates is focusing on prevention and the cost of non-conformances, or otherwise known as the cost of poor quality. So the cost of poor quality is really can be a more accurate description of what we want to control. It's usually easier to identify when it comes to services that directly impact external customers. Most systems, computer systems, can report out metrics around external quality issues that lead to lower customer satisfaction, or metrics to leverage. Could be things like percentage of rework, cycle time, customer satisfaction survey results, claims, write-offs, fines, and impact of competition perhaps. But the challenge lies in measuring the cost of poor quality that have indirect customer impact, and that's sometimes referred to as the hidden factory. So the hidden factory is really defined as the useful, extra, positive output that would theoretically be possible if the resources used to create waste were free to make good quality items. So in 77, Armand Feigenbaum estimated the waste within the hidden factory might be 15 to 40% of total company capacity. That's astounding to me. 40%. That means that 40% of your capacity of your entire organization could be spent on the hidden factory, which is basically producing scrap for you, producing rework. So 40% is pretty high, but 15% probably is not unrealistic. So when your company determines the cost of poor quality metrics, those are only the measurable costs that can be pulled from databases like manufacturing execution systems or ERP systems. However, that's only the tip of the iceberg. So it's easy to measure missed deliveries, product recalls and redesigns, rework activity, and test costs, but these are only some of the costs incurred by a company, and they're usually described here as a visible portion above the water surface of the iceberg. So a company will never be able to measure all of this cost of poor quality, But it's important to remember that the remaining immeasurable costs are always going to be much higher than what's actually measured. Just like an iceberg, the larger portion is below the surface and is not typically visible in the databases of typical systems. You can see many examples of the hidden factory costs below the surface of this iceberg. So all of these hidden factory tasks and activities for internal detection and rework dramatically reduces capacity, and it also creates friction among departments, resulting in frustration among employees. Activities like excessive overtime, billing errors, expediting, damage to your reputation, excessive customer audits and meetings, compliance failures, loss of customer goodwill, staff morale, excessive employee turnover, excessive work in process, loss of potential revenue. These are all very expensive adders to the cost of poor quality. So the cost of poor quality increases as we move from prevention to internal rework to external rework. So the goal is to invest time and money on defect prevention, and this eliminates as much as possible the inspection, the internal and external rework costs. I want to just show a quick video here. It's about 5 minutes, but it's a very good demonstration of poor quality, and really you can see that quality can mean the difference between excellence of an organization and complete and utter disaster. The various examples here I think are all well known to everybody, so kind of sit back and watch this.
Engines throttling up, 3 engines now at 104%.
Challenger, go with throttle up.
Looking very carefully at the situation. Obviously a major malfunction.
Nancy and I are pained to the core with the tragedy of the Shuttle Challenger. This is truly a national loss.
Deeply sorry for any accident that Toyota drivers have experienced.
they potentially had the best answers, so I know whose ass to kick.
All right, move on here. So that's a pretty interesting video. So probably learned during it that we need a truly systemic approach to quality. So in order to not only effectively track but control your company's quality, it's imperative to have a quality management system that's connected directly to production and even maintenance. Any other approach will not have the necessary effectiveness and will never have the ability to provide the automatic real-time control and monitoring that's really needed. With a production-connected quality management system, you can dramatically reduce your cost of poor quality. And doing so directly leads to these types of things: more profit without increasing sales. So many organizations will have true quality related costs as high as 15 to 20%, with some going as high as 40% of total operations. A general rule of thumb is the costs of poor quality in a thriving company will be about 10 to 15% of operations. And effective quality improvement programs can reduce this substantially, thus making a direct contribution to profits. So what's your profit percentage right now in heat treating? If you reduce your cost of poor quality from 15% to say 10% and everything else remains the same, you've just significantly increased your profit, perhaps even doubling it. So what's the ROI on a system that can help your company do something like that? We all know how fleeting profit is in heat treating. This is an opportunity to impact your profits in a huge positive fashion and should really not be overlooked. Dramatically reducing your cost of poor quality can yield more capacity, and that's more capacity without buying new equipment, more capacity without hiring more people, more capacity without running more shifts, and more capacity with less overtime. Dramatically reducing your cost of poor quality can also yield increased sales. You get faster velocity through the shop, which leads to increased throughput and to much better on-time delivery performance. And I think everybody's experienced customers that if you can exceed their expectations on delivery, because from my understanding, in the whole manufacturing cycle, everybody tries to gain all of the losses or the overtime that's been spent producing the parts at the heat treating operation. Of course, that should take zero time, and they can get back all of this time that they're behind already. But so if you can exceed their delivery performance expectations, generally you're going to be getting a lot more work from that company. Also, dramatically reducing your cost of poor quality can yield shortened audits. They can take half the time or less because, as I mentioned earlier, you should be able to answer yes to every auditor's question. That's how that happens. And also, dramatically reducing your cost of poor quality can yield improved employee retention. Why? Well, because the morale is better. If you're not having such a large turnover, then your recruitment costs are going to go down. And without that turnover, your training time and budgets for training can be dramatically reduced as well. So in closing here, I just want to remind you that 4 points here. 1, quality is free. The cost of poor quality is a better metric for determining quality level. So if your cost of poor quality, if you determine it's more than 15% of your operations, then you really need to take a look, because there could be something very wrong in your business if that's the case. Number two, a fully integrated quality management system is a necessary requirement. It's not a luxury. If you have a disconnected quality management system, it's severely limited. And if you have a manual quality management system today, that is a huge competitive disadvantage. You need to understand and track and manage your cost of poor quality. It is possible. You can dramatically reduce your cost of poor quality through a systemic approach using technology designed to marry quality, production, and maintenance. And with a properly managed quality management system connected directly to all the areas of your business, you should be able to answer yes to every auditor's question. And why is that again? Because the parts could not have been shipped if the answer wasn't yes at every step during the processing of those parts. So with that done, if you have any questions on this video, obviously you can't ask questions, but what you can do is you can always contact me. Send me an email here, todd@go-bluestreak.com, and I'd be happy to answer any questions or give you some more information. And I thank you for your time today watching this presentation, and hopefully you found it useful. Thanks much.